All right, Colts, so there's 1.4 notes. We're going to be talking about angle measure, and our objective is going to be to measure and classify angles, identify congruent angles, and the bisector of an angle. So for our 1.4 notes, we're going to talk about ray. Ray is the part of a line that has one endpoint and extends indefinitely in one direction. So it's named by stating the endpoint first. It's very important. Then any other point on the ray. So in our case here, we have our endpoint as M, and we have the point P, and we have the point Q. So in this case, we can label it as ray MP, ray MQ, as long as we have M as the first letter, start with that endpoint, or we can just label it as ray MP with the line with the arrow on the top, or ray MQ. For opposite ray, if you choose a point on a line, that point determines exactly two rays called opposite rays. Since both rays share a common endpoint, they are collinear. So if I have one ray, JK, and then my second ray, JH, they're going to have a common endpoint of J, and they are on the same line. So I would say JH and JK are opposite rays because of that common endpoint. All right, when I talk about angle, an angle is formed by two non-collinear rays. So different than when we were talking about opposite rays. They were collinear on the same line. An angle is when we have two non-collinear rays that have a common endpoint. The rays are called sides of the angle, and the common endpoint is called the vertex. So as we go through this one, there's a couple things that we labeled. Right, so one of our sides here is going to be YX is the way that we label it. We start with that endpoint of Y. If we look at our other side, it's going to be YZ. It's our endpoint, and then our point on the other side of our line. And in this case, because Y is here, this is what we're going to call, the common endpoint is going to be our vertex. So we label that vertex Y. Another way we can label that is just angle 2. And the reason that being is because we have angle 2 here. We can also label it with the three letters, angle XYZ or angle ZYX. The only thing that really matters when you're labeling it is that you have that vertex as the middle letter. So as we see here in blue, it says, when naming angles, use three letters. The vertex must be the middle letter. So down here, we have a non-example where if you were to label that and you said angle YXZ, that wouldn't work. You got to have that Y in the middle because it's the vertex. All right, moving on to our next definition. We're going to have the terms interior and exterior. So here we just have an obtuse angle. We can label it angle MXP or angle PXM. And I just color coordinated it where I have the oranges, points A, B, and C are going to lie on the interior. They're on the inside of that angle, and points D, E, and F are going to lie on the exterior of angle MXP. So, and feel free to pause the video to write this down in your notes. Okay, when we talk about degrees, angles are just measured in units called degrees. If I have a semicircle, so half of that circle, or if I have a straight line, like when I have opposite rays, it's going to equal 180 degrees. If I talk about a whole circle, and I'm going completely around in one rotation, it's going to be 360. And then when I have one where it has our little box, we're going to have 90 degrees. Now, something we talked about today in class is you got to be careful. Do not assume just because I draw a really nice angle and I ask you how much what the angle measure is of that, don't assume that it's 90. It could be 89.2 degrees if I don't have that little box. So don't assume that it's 90 degrees just because it looks like it. And then talking about 90 degrees, just some of the measures here that we have. 90 degree angle, I have that box I talked about. The M stands for the measure of angle, and in this case we could say cab or measure of angle A, and it equals 90 degrees. Okay, and then over here my little arc, hopefully it makes sense, is to signify this little box. When I have that, that means that it's 90 degrees, even if I'm not super great at drawing it. Okay, or if you see a diagram on a test or something that you're taking, if it has that box, you can assume that it's 90 degrees. And then sometimes I'm going to have ones where I have opposite rays and I'm given a 90-degree angle on one side. And because I know they're opposite rays, it's equivalent to 180 degrees. So I can assume, I can calculate actually, that this other side is also going to be 90 degrees, even though it does not have the box, the little square, because the other side is 90 degrees. All right, moving down to acute angle. An acute angle is between 0 degrees and 90 degrees. It's super important. They like to ask this question a lot. I'm going to ask you to give me the possibilities of this angle if it was acute. And so when you go to do your calculations, you set up an inequality where it is less than 90 and greater than 0. Okay. For obtuse angle, it's going to be between 90 degrees and 180 degrees. So similar thing, but this time it's going to be less than 180 degrees and greater than 90 degrees. Angle bisector. So we have this angle XYZ, and then I have this ray right here, YW. So because I have these little arcs right here that are in pink, and they have those little tick marks on them, those little tick marks signify that the angles are congruent. Okay, if it looked like it was just split in the middle really nicely, but I don't have the tick marks, we don't know that they are equivalent. Another way to signify is if I have double arcs or just single arcs. Sometimes in your textbook, they'll just be like a red arc signifying it. And then we have ray YW is the angle bisector of angle XYZ. So we could conclude that angle XYW is congruent to angle WYZ. We can also conclude that if I add the measure of angle XYW plus the measure of angle WYZ, it equals the whole angle XYZ.